So that is, of course, the Henry's Law reason behind that. But what happens, that's called the bends. All right. Well, what happens if you go extremely deep, like 200 feet, breathing compressed nitrogen? So much nitrogen gets dissolved in your bloodstream that it has a narcotic effect, so you feel drunk. All right. So you're on the bottom of the ocean, 200 feet down, and you're starting to feel drunk. So what happens when you're drunk? What happens when you're drunk? I'll stop that. You do stupid stuff. Someone over here, who said that, right? The most conservative person in the classroom, you do stupid stuff, right? So you do stupid stuff, all right? You forget to do things, you're just running around happy, whatever, lose kind of track of time. Of course, that is not what you need 200 feet down, all right? Because then you run out of air and you're dead. But you really don't care about it because you're drunk to start with. Does that make sense? I'm being very serious, all right? Now, certainly you can go that deep, but you can't just do it with normal nitrogen, or you're not supposed to. Right. Normal compressed air. All right. How are we doing? Henderson, okay, now, ideal gas law. Okay? The ideal gas law is this one. PV equals nRT. Ideal gas law. The good news is this is the last one from the chapter, right? Ideal gas law. I'll explain it. I'll give you some problems to work. We'll take a break, come back, I'll work them. We'll be good to go for this chapter, I hope, right? All right, so here we go. P is for pressure, V is for volume, R is the ideal gas constant. That is always 0.0821 liters atmosphere mole Kelvin. T is temperature, and what unit must temperature always be in? Kelvin, wonderful. And then N is the number of moles. See, I told you the number of moles was directly related to pressure. All right. And a lot of times, gas phase chemists, silly gas phase chemists like me, you can interchange pressure and concentrations. All right. Not always, but for a lot of applications you can. So you don't need to go through some kind of big calculation. You just read the daggone pressure gauge off. All right. All right. Are we good with this? Okay. Now, why would you use this equation versus the first one, the combined gas law? You see here, nothing's changing. They just give you a set of conditions and then drop it. All right. One other thing I have to tell you about, and that is STP. What does that stand for? Anybody know? What does it stand for? Stop. The standard temperature and pressure, right? All right. And what the standard temperature and pressure is the standard temperature is 273.15 Kelvin, or 0 degrees centigrade. But naturally, you're going to use 273.15 in these equations. And the standard pressure is 1 atmosphere. So as you're reading your problems that I'm about to assign to you for the next half an hour or an hour, it's this. If it says conditions at STP, you immediately know that and that. You always know R. So that means they have to give you a volume, right? Or they have to give you a number of moles, 1. And then you solve for the other one. Are we cool? R is always constant. It's what's called the ideal gas constant. It'll always be that number right there. All right. Okay, let me get started on a couple of these examples. $11 is a good one for the combined gas law. $19 is a good one for Dalton's law. $23 is a good one. 27. And 48. Okay. So what I've just done is over the past hour, I've just given you the quote-unquote theory behind all of these. All right. Now we're going to do an example from each section, and then we'll come back and talk about it. Is everybody clear? All right.